In this video, we'll continue setting up a new VLAN in our network using Proxmox as the routing device. We'll create VLAN 20 and assign IPs from the 192.168.20.24 range. While we won't configure any switches in this tutorial, this setup can be expanded to integrate with other network devices. Let's first do a quick recap of what we've so far. We have our Windows Server 2025 VM, which is currently assigned to the default VMBR0 bridge. On our Proxmox node, under the Network Settings, VMBR0 is the main bridge providing internet access to most of our VMs. You can disregard VMBR1, as it was created for testing purposes. To verify connectivity, we successfully pinged Google and other VMs on the network. The VM obtained its IP address via DHCP. Now let's go to our node and select Network under the System menu. Next, we'll create a new Linux bridge by clicking the Create button and selecting Linux Bridge. Enter an IP in the 192.168.20.0/24 range. I'll be using 192.168.20.5. Since this VLAN is not being used anywhere else at the moment, we don't need to enable VLAN Aware mode for this interface. However, if you do enable it, it won't affect this configuration because we are not interacting with any other VLAN Aware devices. Once we've confirmed that our bridge interface is configured and active, we need to assign our VM or VMs an IP within that range. To do this, go to the VM settings and change the bridge it's using. By default, it was set to VMBR0, so we'll switch it to VMBR2, the new bridge we just created for this network. Now, manually configure the VM with an IP address from the address range you've chosen for the new VLAN. Now we want to prevent this new VLAN from reaching our main network while still allowing internet connectivity. To achieve this, we'll use Iptables, but you could also configure this through the Firewall under the node's configuration menu. Let's navigate to the shell and apply the following Iptables rules. I'll leave them in the description. In general, the Iptables iForward command inserts a rule into the forward chain, which is used for traffic being forwarded through the Proxmox host, not traffic destined for the Proxmox host itself. The numbers after forward indicate the rule's position in the chain. I and O specify the incoming and outgoing interfaces. J defines the action, such as allowing or dropping traffic. -M conntrack ctstate, related established, ensures the rule applies only to packets that are part of an existing established or related to one related. Rule breakdown. 1. Allows return traffic, replies from VLAN 1 to VLAN 20 and related connections. 2. Allows return traffic, replies from VLAN 20 to VLAN 1 and related connections. 3. Blocks traffic originating from VLAN 1 and destined for VLAN 20. 4. Blocks traffic originating from VLAN 20 and destined for VLAN 1. 5. allows traffic originating from VLAN 20 to access the internet. One important thing to keep in mind is that Iptables rules are executed from top to bottom. The first matching rule for a packet is the one applied, and any subsequent rules are ignored. That's why it's best practice to carefully plan the order of your rules, starting with the most specific and moving toward more general ones. After applying the rules, we need to save and make them persistent to ensure they still work after a reboot. Iptables save, iptables/rulesv4, net filter persistent, save. Finally, confirm that the configuration has been applied using iptables l/vn line numbers. Now our VLAN traffic restrictions should be in place. At this point, the 0-byte and packet counts confirm that no traffic has matched these rules. With the configuration complete, let's test internet connectivity and bidirectional ping between our main network and the new isolated VLAN. As you can see, internet connectivity is confirmed by our successful ping to google.com. However, we're unable to reach the VM on the 192.168.024 network. Let's now test connectivity between that VM and the Windows VM on the 192.168.2024 network. The configuration is working as expected. Traffic from the 192.168.0.24 network is successfully blocked from reaching the new VLAN. If we check the rule counters again, we'll see that both the byte and packet counts have increased, indicating that the rules have been applied to traffic. As demonstrated, we've effectively isolated the new segment from our main network while still providing it with internet access. Thanks so much for watching. If you found this video helpful, don't forget to give it a thumbs up and hit that subscribe button so you never miss out on more simple tech tips. If you have any questions or suggestions for future videos, drop them in the comments below. I'd love to hear from you. See you in the next video on BiteofTeck.